Thanks for coming. I'm Antonio. I'm working in Schibsted as I'm a software engineer in infrastructure team. And today we are talking about practical aspects of microservices. And I'm trying to share with you our experience in using in production and building microservices. It's not meant to be the source of truth, okay? It's just our experience, and you may have a different experience, and I'd love to hear about it. So, what are microservices? I think you are here, you already know what they are. It's a new way of thinking application. If you think in the Unix style model, you come from an application like this one. It's what is called the monolith, okay? Oh, like, I have a monitor here, nice. So it's called a monolith, so a big application that to everything. In this case, it just gives you the customer list with some parameters. It's sorted, no duplicates, only the name. To something like this one in the pure Unix philosophy. You have a set of processes that collaborate and communicate. In this case, they communicate over the pipe, the IPC, and to obtain an high-level behavior, okay? So in terms of services, you come from an architecture like this one. It's called, we call it monolith. This is a simplification, okay? I think no one will put something like this really in production, but I'm just taking the extreme, so to make the concept clear, where you have one big application, let's say it's your CRM, that exposed to endpoints API, you have one big storage, and all the logic or the business logic is there. You move to something like this one. I think I can zoom it. Okay, something like this one, where you have a set of services working together to obtain the same results. So from this picture, you can already spot the complexity of putting something like this in production. You have different services, they need to communicate, they need to discover each other, they have independent storage, they communicate over APIs, endpoint. So wait. What happened? Okay, so just to be clear, is the monolith bad? No. It's not having microservices all the costs. It's an approach that has been around for years, and it still has some value. And it's not that you should use microservices at all the costs. It's just like trying to find the right balance in the complexity of having the monolith and deploying microservices. So if you decide to go down the road of microservices, you have to know that the world will never be the same, because deploying microservices will impact you in different aspects. Like deployments, you are going to deploy a lot of services, and these deployments should be coordinated. You are going to monitor and logging different instances. You are going to think your scaling in a different way. You are going to have to deal with something like discoverability, that it's a new thing. You have to deal with configuration problems. You have to deal with dependencies between services. You have to deal with different kind of troubleshooting. You have to deal with different pattern of development. So first thing, we'll try to agree on a definition of microservices. There are a lot of definitions. I'll just pick one. This, I think it's a good one. It's from Martin Fowler. And they say that microservices, it's an architectural style for deploying a single application as a suite of small services each running its own process and communicate it on lightweight mechanism. This lightweight mechanism is generally RESTful, RESTful API. I think it's a good one, and of course many other definitions are around, but I think for the context of this talk, this is a good definition. And also, another way of seeing it from Adrian Crockford when he was a cloud engineer in Netflix, it's like a fine-grained SOA. It's a bit stretched, but it gives the idea. And it introduced the concept of componentization by services. It's the same componentization concept of software engineering, but it's moved in the service context. It raises a new type of question, like what is a component? And we can say that a component is a unit of software that can be independently replaceable and upgradable. So you start seeing how the complexity of microservices start growing. And new question like, how small is my component? Do I require a new component for this new functionality? And whatever. Just a tip, a golden rule to answer these questions is the single responsibility principle. One service should do one thing and should do it better, the best way. So if we wrap everything together, we say that we have a set of small services. They are independently replaceable, they are upgradable, and they need to communicate to complete a task. It's like an ecosystem, a natural kingdom ecosystem, where you have a complex emergent behavior, and this behavior is the result of combining small and simple behaviors. And it can evolve. So you can see the complexity, and today we are going to talk about how to deal with this complexity. So first thing, you have to deal with dependency. You have microservices that needs to talk to each other. They need to know how they can talk. So a good approach is to document the contract between your microservices. There are tools around like Swagger or ARAML that will allow you to define the API, to document it, okay? And it gives you a nice way of testing it because it generates a web form, a web application to test your interfaces. Also, it's very common to have a client SDK, something that allows you very simply to talk with your services. And if you use tools like Swagger or RAML, they can generate the SDK for you. So from the API definition, they generate the client. The client at very basic level should be something very simple, something that allows you to talk with your client, and there is no extra logic in it. It just has to know the endpoint, the HTTP pair that they are accepted, and then they use it. Then on top of it, you can build your business logic. Or you can go to the path of having smart clients, leveraging technology like ATOS or Alps, okay? It's something like having hypermedia services where each time you have a response from your services, you have metadata in it that tell the client what's the next endpoint or what are the endpoint accepted by the microservices and what are the parameters. Also, if you are going to write your own client, it's just there are a lot of tools that allows you to write client just defining API. The interface, like the retrofit library in Java. This is an example of just invoking a client for GitHub. You define the interface, you instantiate the retrofit, and you just invoke it. And that's it. You don't need to reinvent the wheel. You have contracts. Your services follow contract. But at some point, you need to change this contract because your application evolves. So you are going to introduce breaking change. You should avoid it, but sometimes it's required. So you have to deal with this breaking change. You can cope with them. And generally, the client should cope with this issue. Smart client, if you use smart client, they generally have a good behavior when your change is about changing the endpoint name or changing parameters. They can adapt their behavior based on it. But when you're releasing something server-side that is a breaking change, you should make sure that the client can handle it. So basically, what you try to do is to have this feature is supported in the client first and then deploy it on the server. And if possible, when possible, you should try to always maintain the old behavior side by side with the new one. That doesn't mean to have legacy code and code that you will never throw away. It just means to gradually move to the new behavior and, if possible, deprecate it and then you remove it. Also, if using feature toggles pattern, it will be helpful to synchronize the client and the server behavior. Also, your client should be tolerant. This is an except of the TCP specification. It's called the robustness principle, and say that you have to be conservative in what you do and liberal in what you accept from yours. That means when your client receives a response from a server, just take into account that utilizes only the bit of information that you need. If you have a JSON, there's no need to validate the full JSON. Just take the part that you need, and that allows you to do what you have to do. If the JSON changes in some parts, in some other parts, and this part doesn't affect you, it's fine. It's okay. You can adapt to changes. If you have to introduce very big change, like big refactoring, so you can take into account to have versioning. You can have versioning at API level, or you have a new kind of versioning using microservices that at service level, you can deploy different version of your services and have mechanism to switch from one version to another. We can see it later in the deployment part. As Netflix say, the fault tolerance is a requirement, it's not a feature. So this is the theory behind tools like the Chaos Monkey. So you should think about your dependency as something that can fail. So you have to deal with this failing. For example, you can use retry logic on API calls, and you should fine-tune your retry logic. Also, you should retry on safe operation like get. Okay, but if you have a post, can you retry on it? Post is not meant to be a safe operation. It's not idempotent, so calling post 2 times means creating 2 different resources, but there are techniques to transform a post in something that is idempotent. You can call many times, and the result is the same. So take this into account. Also, timeouts. You are dealing with an external dependency. You have a timeout. Generally, the default for a timeout for a client library is 30 seconds, 60 seconds. This can be something good for web clients or HTML response from a web server. But in terms of microservices, this may be a huge time. So just measure it and tune your timeouts. Also, bulkhead. Try to isolate failures. See if something of your microservice is failing, try to isolate this failure in order to not affect other parts of your microservices. If you are dealing with external dependency, you can, for example, isolate the thread pools and have a thread pool for each microservices. If your thread gets consumed by one service getting very loaded, you are not impacting on the other dependency, for example. Also, there are many libraries that implement this pattern, this circuit break pattern, when it comes to dealing with external dependency. So if at some point the dependency fails, the circuit gets open, so no more requests going to the services. This have 2 effects. First one is to fail fast, so you know that something wrong is happening. Second, if the dependent microservice is not working because there is much load, opening the circuit on the client will allow you to load the pressure on that microservice, so lower the load and just give it time to recover. Then after a certain time, if the circuit goes to the half open state, and if the sequence request goes well, it got closed, otherwise it returned to the open state. For example, Netflix has the Istrix client. It's a very good piece of software. It implements all these kind of things, like also the circuit breaker, and also give you nice graphs on what's happening. Each of these one is a command. The command, it's an external invocation. It gives you real-time graphs of what's the state of the circuit, if it's open, if it's closed, what's the traffic going into it, and whatever. Also, dealing with deployment. So you have microservices. You need to deploy each microservices many times a day, I will say. It's following the continuous deployment approach. You cannot do it manually. You need something automated. Everything should be automated, from your merge into master, from deployment to production. You may need to use a continuous deployment pipeline. We are doing it. We started moving to pipeline. We joined this project, Spinnaker project. It's from Netflix, basically, from Google also. It's a full pipeline solution. It's based on microservices. We are contributing on it, and we are finding a lot of advantages using it. This is just a snapshot. This is from yesterday, and this is the dashboard of Spinnaker. These are all microservices that compose the Spinnaker ecosystem, and this is an overview of the pipelines. And while I was taking the snapshot, we have just 2 pipelines running, the Cloud Driver and Front 50, just deploying Spinnaker. And this is Spinnaker deploying its own microservices. It's like an inception. It's mind-blowing, but it works. And also, you can define a pipeline like this one, where from your trigger, that can be a commit on Git, or can be a CI job, a successful CI job. You have the bake stage, where you bake your deployable, the AMI, the container, whatever. You can deploy into the dev, you can run tests, you can have manual judgment, you can deploy to production, you can run smoke tests, and decide if you want to roll back or not based on some metrics. And everything is automated. And when you start working with microservices, this is something very essential. You may need an API gateway. Why? Because microservices exposes API endpoints that are very fine-grained. And these are the kind of endpoints that you don't want to expose to your customer, to your client. So you can aggregate and consolidate this API to an API set that is usable by your client. Also, you can move a lot of logic inside the API gateway. They can handle authentication for you. They can handle monitoring. They can handle accounting, logging, load balancing. It's a very nice piece of software to have. And there are many products on the market for it. There is Nginx Plus, you can use for it. Netflix has its own component, Zool. You can use, for example, AWS API Gateway. You can use software like TYK, Kong. There are a lot. Just go on the web, find these tools, compare them, pick the one that works for you, and just try it. Configuration. You are not dealing anymore with one server and this life cycle. You are dealing with a high number of possibly short-living instances. You may need to spin up these new instances because you are scaling. And it has to be fast, it has to be reproducible and safe. So the whole way of running configuration software like Chef, Puppet, Ansible, the one you like, it doesn't really work when you are dealing with microservices. They are good tools to configure your, let's call it, image, but then what it works is having a pre-built image, something that you can just spawn up and run. It's already configured, everything is already there. When I talk about image, I talk about, for example, containers, whatever you want, Docker, Rocket. Instance images like AWS MEI, like Google Cloud, images. And a nice tools to deal with images is Packer from HashiCorp. You can create different images from the same source. And another consequence of having these pre-built images is moving to the immutable infrastructure pattern. I don't have time to talk about it today, but if we want, we can discuss it later. Also, monitoring and logging. It's the same. You are going to monitor and log from a high number of short-living instances. You should use a tool that monitor at scale. That collect metrics and from instances, and then give you an aggregate of these metrics. It will be nice. It integrate with your cloud provider. So it's very nice that you have your service metrics in your monitoring tool. But it's very nice if you can pair these metrics with the metrics that your cloud provider gives you. Pairing your service metric with, for example, the CloudWatch metrics, so you know the metrics from the load balancer or from the compute engine, and you can use both metrics to understand the behavior of your services. In the cloud, there are many tools like Datadog, Stackdriver, New Relic, or you may want to use something on-premise, a lot of solutions, Prometheus, InfluxDB, Kairos, OpenTSDB, Elasticsearch. These are all good tools for monitoring. Logging, the same. The old way of SSH and grep for logs doesn't work anymore. You have a lot of instances, they are all logging, they are producing tons of log. You need to find a way to aggregate this log, understand this log, grep, find, search. So you will want to collect all this log, you will want to index this log in order to have fast search on it. Also, a nice thing to have is alerting on log when something goes wrong. This is something that I cannot always see in production, but it's something very useful. If you have stack trace in your log, you will want alert on it, PagerDuty or GetSentry, whatever. But you have to know that something is happening in your log. It doesn't work that you just go to the logs only when something bad happens. You know that it's happening, and you go grabbing for logs. Also, a nice feature is to create dashboard from logs. You can, if you index your logs, you can filter, you can parse the information, you can generate numbers and value from these logs. You can create dashboard from the logs. For example, for a web server, you can create dashboard of the number of connection or the most visited URL or the number of HTTP 201 status code return, something like that. In the cloud, you have tools like SumoLogic, Logly, Papertrail, log entries. On-premise, you can use tools like Graylog, Splunk, Logstash, ALK, that is a mix between Elasticsearch and Logstash and Kibana for graphs. Scaling. To scale efficiently, you need to understand how the load is distributed in your application. It's not like the monolith, where you have one piece of software, you need to scale it, just means replicate it many times. You may need to scale the storage, sharding, adding nodes to the ring, whatever. But you have different microservices, and they need to scale independently because the load spread differently on these microservices. Also, it's related to cost. Do I need more instances? Do I need bigger instances? We are talking about vertical scaling, horizontal scaling. It depends. You should study the load on your microservices. You should understand it. You should measure it. And you should understand how to scale. And we are talking about a fine-grained scaling. And fine-tuning, it's also related to the cost. It can save a lot of money. You don't need, in the case of AWS, you don't need M4 2x large instances for all your microservices. You may tune it. You can save a lot of money. And also, we are talking about scaling up, but also scaling down. And scaling down is very difficult. It's more difficult than scaling up. Adding new instances is very simple, but when it comes to remove instances, you have to pay attention. And it depends on basically your application. You can have a state in your application, and you want to lose it. It may sound weird, but it's really dependent on your application. I can give you 2 examples. One example, for example, is the bake service we see in the pipeline of Spinner. Yes, it's a microservice itself. It's a packer running. And if I'm scaling down, I want to remove this microservice from the load balancer, or I want to register it from the service discovery tool. But there is a process running in it. I cannot just kill. I have to wait that this process terminates and produce the AMI before killing it. Also, in infrastructure, we are deploying a tool for VPN. It's VPN as a service. An instance maintain an open connection, an open TCP tunnel, encrypted tunnel with the client for the VPN. We don't want scale down and drop this connection. So you have to understand how your application behaves, and you need to put in place all the logic that you need for scaling up and scaling down. Also, discoverability. The microservices need to talk each other. They need to discover each other. What's the address of the microservice I need to talk about? You have basically two ways of doing it. But one is by convention, also called server-side load balancing, and the other one is using service discovery. That is the client-side load balancing. This is an example of server-side load balancing. It's the same example of before. That means that you have each microservice is behind the load balancer. So when the API gateway needs to send a request to the microservices, it just knows the address of the load balancer that it's in front of the microservice and send the request to the load balancer. What's the drawback? You need to know the address. It means they can be stored in a configuration file or in some configuration tools. They can be discovered into the DNS. You should find your way of doing it, but it's a way. That means that you are running load balancer, that it's another piece of infrastructure that you need to deal with. It gives you some advantages and some disadvantages. For example, it can have nice things for you. It can have SSL termination. It can handle sticky session if you need it. On the other side, you have to maintain it. You cannot have a lot of control over it because the loading policy generally is a round-robin policy. Just spread the load across the instances behind the load balancer, so you cannot really choose what instance you want to send traffic to. And also, they can be a single point of failure. If the load balancer fails, the connection to your microservice cut down. If you're using cloud system like Google Cloud, like AWS, this is not a big issue. They are redundant, they're elastic load balancer, but it may not be always the case. The other way is service discovery. That means that each microservice is registered to a service that is the service discovery service, and they have on the microservice itself, there is something that is called the client load balancer that will fetch this information from the service discovery, so get the list of instances registered for that service and just send traffic to them. It's configurable, it's your side, it's client, you have control over it. You can decide how to spread this load across all these instances. Also, it's for example, the versioning we were talking before, you can decide to deploy 2 different versions of your microservice, the new one and the old one, and you can register these 2 versions with different version name in the service discovery. At this point, the client can decide if he still wants to use the old one or the new one. When everything is migrated to the new one, you will have 0 traffic on the old one. You can just drop that instances. So it's not applying versioning at API level, it's applying versioning at the microservices level. There are many ways of doing it, and many tools. In the Netflix open source stack, there is Ribbon, or you can use tools like Zookeeper, Eureka from Netflix, again, and Consul from HashiCorp, or you can use DNS service discovery. There's another way of doing it, so it takes advantages of reusing an infrastructure that is already in place, the DNS. It may not have all the flexibility of the other system, but for some extent it works. So new instances will register to a DNS in TXT or SRV records behind a known CNAME. So when you need to connect to one of these instances, you query the DNS, you have the full list, you pick one, and that's it. Also, new way of develop and troubleshooting your application. You need to have a good story around your dev environments. When you are developing, the developer may need a full set or a subset of microservices running on its own local machine. And it's something that should be easy to set up, easy to maintain. It should not be painful for the software engineer to handle with this environment. Some approach, you can provide a VM, for example. Vagrant is a good tool for it. You can provide a VM, a pre-configured VM, or a VM with a provision script that can be, again, a custom script or a tool like Ansible, Puppet, Chef, a configuration management script. Or you can use containers. Even if you are not using container for deploying in production, it may still have value to use container for dev environment. So you can easily set up a new Docker host with Docker machine. You can easily use Docker Compose to orchestrate or your microservices. Each microservice is a container, so you can orchestrate your container and you can spawn up the full ecosystem of your microservices. Also, when you have this Dockerization in place, it's quite helpful to use the combination of Swarm and Compose to just deploy a full stack of your ecosystem, of your microservices ecosystem in a dev or integration environment. So you can run tests against it, you can run integration tests or performance tests, load tests, whatever you need. Also, at some point, you are dealing with external dependency or your internal dependencies, your internal microservices. You need to test your connection. You may need to something like stubs when you run unit test code. There are tools that allows you to do this, like Mountebank is just a service stub. So you can define how the behavior of your services, it can run on a specific port, it can accept some requests, it gives you mocked response. So it's very easy it's very useful for integration. It's very easy to use, it's very powerful. Also, you need to, since we are dealing with microservices that can fail, you may want to use failure injection testing. There are many tools for it. Well, not so many, I found 2 or 3, but they are useful. It's like having a proxy on top of your microservices, and you can inject failure, dropping connection, packet dropping, jitter, latency. You can pilot it, so you can understand how your microservices behave in response of this failure, and you can tweak and tune your retry, your timeout, your fallback logic, whatever you need to cope with this. Also, a new concept is distributed tracing. A request come in your API gateway, the request goes all through all microservices, maybe bouncing from one microservice to another, and you have the response. At some point, this process failed. There is an error somewhere, and your API gateway is returning 500. So where is the problem? What happened? In which microservices? Using distributed tracing, Zipkin is a nice tool for it. Will allow you to trace your requests. The idea is to add a unique ID on the request, and with this ID, follow the request inside all the microservices, aggregate all this information, so you can see all the path and all the requests and response for all the microservices to discover what happened inside your microservices architecture. Also, if you analyze a piece of traffic with this kind of tools, it's very useful to understand how the data move around your ecosystem. You can find loop. You can find that you are calling a microservices 100 times, because maybe you are calling a function for one item 100 times. You may optimize it. You can call it one time passing a list, for example. So it's very useful for introspection. And that's all. I went very quickly because we were late. And do you have questions? Yeah.
Okay, I have 3 questions. I don't know if I have a limited amount of questions to ask, so I will just start with the first one. You mentioned that when working in a microservices architecture, one of the very basic things is scaling each separately. In my company, we're trying to go this way. I don't think we're using microservices, but we're on our way. And one of the things that we find difficult to let's say, configure is, or to know about our services is how do they scale independently? Like, we have a single entry, for example, and then that
Yeah, what, sorry?
we have a single entry point
Okay.
for, say, a specific system, and then that specific system is separated into different services. But each service gets a different load depending on the calls that it receives.
Yeah.
So one of the challenges that we are facing is how do we do stress testing or load testing or something similar to that, so that we get to know how each of the services is loaded.
Okay, the way we're doing is we set up like a stress test environment or an integration test environment, and we use tools for stress testing. For example, you have Locust. It's a tool for load testing and stress tests. So if you put in place all the metrics you need to understand what means stress on your application, it may be CPU, it may be memory, it may be I/O, it may be network throughput, and you can tune your stress tool like Locust to send that kind of request at that rate, and you increment it. You will see emergent pattern on it. It's very, if you have a dashboard with all your metrics and you have aggregated metrics for microservices, it's very easy to find microservices that start to suffer. Also, if you are using something like Eastrix, you have a real-time dashboard of all your external dependency, and something goes wrong, you can see this. Let's say, I think it's something here somewhere. Yes, when something starts to go wrong, you can see the green circle inside just growing because requests are growing, that start becoming red, and at some point the circuit break. So the circuit open, and you see that service is the other side of this command is failing. So you can go there and inspect that. It's find your way, okay, but you have tools for it. You should leverage on metrics, on dashboard. You have to try to log and measure all the relevant aspects of your microservice, and just use stress tools. That's what we do, and we are having a good response from this approach. Yeah.
How do you do it in let's say, real environment without crashing the real environment?
As far as I know, we are not running stress tests on the real environment because it's going to affect the production behavior. We run stress tests of clone of the production environment. We are trying to simulate client requests, and we are seeing how our microservices respond. And sometimes we found bug, and we fix them bug, release them in production, and we see that after this bug fix, after our stress test, some metrics start dropping. I mean, some CPU spike or some JVM heap spike, they start normalizing. Okay, this is the way we do it. We don't do it in production right now. Stress test. We do smoke tests on deployments, but not stress tests.
Okay. I was just asking that because sometimes it's not the same the real environment than the pre-production environment. But anyhow, I will just pass this to someone else who would like to ask something.
Hola.
Hola.
I have one question. I mean, the Schibsted is a big group, heterogeneous, a lot of little companies and big companies and different tech teams. How are you managing to infuse the microservices called into all of the different companies? Because one of the main problems that we're seeing is that it is difficult to convince people to get out of a monolithic architecture.
Yeah, I agree. It's difficult. So basically, I work in the infrastructure team. So our objective is to create a common infrastructure for all the teams and all the small companies, big and small companies that are part of Schibsted. So what we are trying to do is to teach by leading. You know, we are trying to apply this best practice or this way of doing it, and we are just showing other how we do things, and we are showing this kind of tools. For example, for Spinnaker, we start using pipeline. We deployed it internally for ourselves. We start using it. And then we went to other teams and we said, look, we are using this. We are having these advantages. Our bake time dropped from 12 minutes to 3 minutes, for example. We have this kind of control of our deployments. Or we open a dashboard like this one, or Turbine, that is an aggregation of all these Istrix dashboard, and we say, look, this is our production environment, and we know exactly what's happening. Do you have something similar? Most of the times the response is no, and they say, whoa, this is very cool. This is how we are doing it. You need a good leadership, a good ownership in the company to push this technology. But I think the only thing that gives value is not talking about it, it's doing it and showing it.
It is not mandatory.
Sorry?
It's not mandatory.
It's not mandatory. It's not mandatory. There is a high degree in teams on which technology they want to use. But we are trying to push in this direction. That it's not microservices at all. When I say this direction is good practices, best practice, or choose the best tools. Thanks.
Thanks.
Thank you.